Oh, we need to unmute. That's important. All right. Today is the big day, okay? We're recording this shit. But before, allow me to check if we don't have the end of the world, okay? I need to know. I need to know. Okay, let's go to routers. Are we dead yet? US and Iran both declare victory as ceasefire is agreed. Alright, based. Alright, so the US is still being retarded, but could be worse. Ooh, those are big ass numbers. Let's go check the stocks. Let's go check our stocks. Ooh, that looks pretty good. Oil is getting a battering, which is expected. But it's... okay, people are very cautious. And if we take a look, that's my position. Alright, we're making some cash. God damn. That's good. I'm definitely back to pre-war level now. I'm doing good. Alright. We're doing good. Let's get started on this. Let's keep a page open. Let's close what's not important. Let's open this. Alright. Hi, MB. How's it going? My stream is like your alarm clock. I'm like, wake the fuck up! I'm here! How's it going? So, the plan today, we're making a test run. So we're going through everything and I'm trying to like do it seriously. But with the full like assumption in my mind that I might not have all the information. so that I don't feel bad about checking a bunch of shit. So that's the first thing that we're going to do, and after that we're probably going to run this again. Now let's just get a quick look. Alright, nothing has changed here. That's great. Now, in which order do we want to do this? There's like two main questions, is how do I intro? YouTube is sensitive with the comments this morning. Like, I find it triggering that YouTube will remove comments from my fucking moderators. Like, I would expect YouTube to leave comments on. Like, you should be able to say insane shit. Okay, trying to get back my account from Canada Post. So you're losing your account from Canada Post. Are Canada Post account that bad? Are they that hard to work with? Oh well, they must have strengthened things a little bit, being that now they manage also like money. If I send that same to comment only one post, it doesn't get through. I guess it's the combination of get back, send the package, and the ominousness of someone. Weird. Alright. Let's focus on this. Maybe. I agree. Alright. So do I want to start on preemption? I think preemption is a good start. That's pretty much the biggest of news. I'm not sure about AMD translation being second. I don't know if it's that interesting. What other thing, from what we researched, What other thing feels fun? Because we need to put the most fun things at the top so people hang on. Was there a thing that you were like, oh man, I want to know that? And I want to lay down what I'm going to say for the intro. Intro. So normally I have 3 things. I am not pleased with what most people find pleasing. Assume that they're all complete nerds, okay? Because to me, like, this is not even that interesting. This is interesting. This is like chief. This is top for me. But I know that people like may find this a little bit weird. So, yeah. Like, in memory management is like pretty high on my list, but it's not one thing. It's a lot, right? I don't know. Let's just take half a second to try to destroy. Preamp thing will be interesting if you explain how it makes a difference. True. Alright, let's go check what the fuck they're talking about it. Like API for error reporting, that's eh. And it comes from it, like XFS now has this capability. Memory management. Oh, I don't care about linking because I don't like my other videos on this. The only one I like is EXT. So. Yes, I have. Folio is a must. We must always talk about it. Like, it's all boring. What the fuck do other YouTubers talk about? What's his name? Nick? Is that his name? Nick? Linux? 7.0? You beat me to... yes, Heavy Nick. Alright. That's some fucking writing.
Another week in Linux and open source news, as we get quite a few updates this week, including the things like the Linux core, graphics, and display stack updates, desktops, and more. Here's some exciting news, as the PCI SIG says that PCI Express 7 is still unscheduled to be released, with some awesome features, including doubling the bandwidth of the PCI 6 specification to...
I'm not saying that we have those specs, but we have.
...to 128 gigatransfers per second.
Alright, what's the link with
This
Linux?
will prepare Linux for future PCI Express devices, and is great because they'll immediately work when they arrive. A big deal for Linux. In another big deal for Linux, another patch, which is seemingly uncovered by AI, has given us a 50 to 80 times boost on idle systems in the IO uring code. You might be asking what IO uring is. It's a modern Linux system for doing disk and network IO, which helps programs use it to move data without constantly having to wake the CPU. And for patch 1, a 50 to 80 times improvement on the I/O U-ring side of the idle systems, where p-poll ends up sleeping for 500 milliseconds while there is I/O to submit. So the biggest winners here are going to be things like
Yeah, but is it a real thing or is it just a fucking meme? Anyway. The slow realization of Linus that it's not because one more week of dev that we got a big release. Yes, hi, Rust. I always forget to say hi. Like, do we care? Okay, we covered that.
very exciting. And improvements just keep rolling in as Linux 7.0 also adds in a
No, HID, no. Okay, I prefer Suicide than that.
Let's keep on going. And if you're ready to level up your Linux experience and you want awesome laptops that are Linux first,
Okay, thank you, bro.
scanning, better file syncing, and bug fixes, this patch series will actually boost performance when accessing Windows.
Bro, that's... How does he make views? This is all fucking boring. I'm not sleepy. Okay, now we're out. Okay. Yeah, maybe I should address that at the start. The 7.0. Like, I could go into... Linus didn't make the version change because of specific features. He make views because he's not only kernel but all kernel. Yes, okay. He makes views because he's consistent. He makes videos like what? Is it every day or every week, or like he always does his thing and he covers a bunch of shit and he adds little tidbit of knowledge. So like that's okay that he makes views. I'm just like fucking confused because to me this is boring as shit. Like, I'm sorry, but NTFS news? Bro, HID change? HID is the most boring shit because it's like, we now have support for this new Asus laptop. You're like, okay. He really sounds AI. This critique is levied to me all the time. Like, people have no view for what AI sounds like. He pops in my suggestion because of you. That's true, okay? Even YouTube. I don't know if they do it anymore because I don't publish as much. But when I go in my setting... Oh, I hope this doesn't fuck something up. When I go in my setting, they actually... Ooh, we got some nice memes. Okay. They literally say... Like, we're passing... where did they say that? Audience. Where the fuck is it? Yes, exactly. Like YouTube is telling me, hey, you're sharing the same audience as this guy. So it's like, okay, cool. Nice. I should probably answer some comments. Anyway. Goddamn. It's going to be hard today. Alright, so it's boring. Let's address the mental effect of 7.0. So, not because of specific review, but people still have a compulsion to push their change onto kernel that is part of a new major release. Is there anything else that I should say? So, even if Linus didn't make the change because of the features, the release is still a bigger than usual release. All right, that makes sense. So I can address that, then do this, then do that. Then I can go through the FS. I don't know, maybe I should go through memory management. Like, FS are cool and all, but memory management, like, there's some big shit in here. Point out that 7 is bigger than 6. Bigger, yeah. Yeah, I'll make the point. Like, I'm not writing it because I know it will fuck my brain, but where I want to go with this is... It's a joke. Yeah, the bigger, better. Yes, but I'll still point out that 7 is bigger than 6. Oh, in number sense. Okay, thank you. That's retarded. Okay. I thought you were talking about, like, the last release is bigger, is smaller than this big release. So, okay, thank you. That's retarded. Okay, I'll give it to you. You know what? Let's go full opium straight at the start. All right. Waiting on the phone, so retarded. Waiting on the phone, so retarded. Thinking is what I do. So retarded thinking is what I do. Okay. Sometimes I just need to read it out loud and I understand your writing. And also, fuck YouTube for putting this on like 2 lines. Just put it on my other screen. Oh man, my brain. Okay, so... Mention that 7 is a reference to the movie 7 with Pitt, Freeman, Spacey. Great movie, by the way. Are you fucking kidding me? I don't even know that's like a movie. Anyway. Another movie guy, okay. I just want to read through this because I have no clue about what it is. I forgot it. Okay, AMD Zen 5 address translation enabled for use with CXL. Okay, let's read that. Nah, I guess that's the only way to fucking say it. So Zen 5 can be configured with normalized address. This feature creates a split between the CXL endpoint and the CXL out. a split in which address type use. This feature creates a split in which address type DCXL endpoint, DCXL host, and the system use. The benefit of this split is the ability to interleave your memory across multiple CXL endpoint. Have they removed the feature that's released? If so, Maple should put it in a box. The end of the video. They do all the time, and I didn't check. That's retarded on my end, okay? That's really dumb. But normally, Phoronix is cool with this. And I mean, it doesn't really mean much because this is not a full thing. Remove. No, it's revert. Okay. Let's just be sure that there's nothing that I recognize here. Self-test, we don't know. Okay. Okay. All right. Okay. Like, the big issue is that I don't know how to do this correctly. If you don't know, in 7, detective, open a box or something. No, I don't know which fucking movie you're talking about. Holy fuck. I don't even know what to say now. You guys are... You guys are being... You're being, okay? You're being. Okay, so we are in the clear. We're in the clear. All right. Forget it was set up for an us reference. Yes, I really don't know. I'm not memeing. I don't watch movies, okay? I don't. Watch it now. Go fuck yourself. It's okay. Don't get mad. We don't judge you. I'm not getting mad, okay? I'm memeing. I'm not really frustrated, okay? I'm all good. I swear I'm not triggered. Okay. I'm having fun, okay? It's banter. Banter. I'm treating you like I'm treating Rust, okay? We do a little, but not that much. Oh, judging? Okay, go fuck yourself. That's you deserve it. You deserve it. All right. And what's the best way to talk about this? 7.0 or Linux 7? Hello and welcome to this new video. Today we are going to talk about the Linux kernels. I want to say 6. Holy fuck. 7.0. Linux kernel 7. I think we're gonna do 7.0. Anyway. And what do we put our emphasis? Linux 007. That would be like I'm getting fucking struck, okay? Copyright. oh yeah. Hello and welcome to this new video. Today we are talking about Linux kernel 6.7. I don't know if that's is that funny? I guess I could just do like a on the 6 and it would like put 7 on it. Yeah, maybe. I'll see how it feels. Okay, so what are the 3 things that I say, right? Because in my videos, what I do, YouTube. Nope, that's not what I want. Oh, fuck. Google ads are not working properly. Let's fix this. My account has been cancelled? What do you mean? Reactivate my account. None of your ads are running. Well, I don't run ads, retard. Oh yes, I want a credit. Are we back at running ads? I guess we are. Okay. That is funny for me because it doesn't feel like a bump in major version. I know why. Do I do 6-7 meme? I don't know. Will people click off the video because of this? Linux 6. 7! Ah, no. I could go full brain rot and do like Linux 6, 7, ah, and just play the intro. Nope, ain't doing this. Alright. So like,
optimization was
shut the
achieved.
fuck up.
Hello and welcome to this new video. Today we are going to talk about the Linux kernel 6.19, crazy optimization, new API, and even some cooperation coming up.
So like the idea is dropping something that's tempting that you want to know about, okay? So what are our 3 things, okay? So we can go for like CR7. I don't even know what you mean by that. Anyway. Okay, so the first thing that we could talk about is preemption. What would be a smart play on word? Preemption. When I look at CR7, it makes me think of a battery, but I don't know if we're talking about the same thing. Anyway, is it a CR3? What's the little button battery? What are we talking about CR7? If I Google CR7, I'm getting Cristiano Ronaldo, like the footballer, like soccer player. Is that what we're talking? Using hands. Yes. Bro. How? Why? I don't care. He's playing sports, okay? And he's not Canadian, so he can go fuck himself. I truly represent my country in the best way. Preemption versus preemption. Are you talking about my speaking right now? Using hands. I'm fucking confused anyway. I don't know CR7. CR7 is Cristiano Ronaldo, the soccer player. Anyway, okay. I had a fucking play on word. Why didn't I write it yesterday? Preemption. Using hand seizing. Oh, that's way too fucking... That's too complicated. Words that starts in pre. Give me a list. Okay, let's... God damn, are those real word or... Freeman? Okay. Bro, those are not real word. Give me this image. Preeminent? Preface? Schedule. Fuck. Do they really? I thought Scrabble, you needed the word to be like in a dictionary or something. I don't know, I've never played Scrabble. Okay. Okay. Maybe there's no fucking... Hello and welcome to this new video. Today we are going to talk about the Linux kernels 6? No, 7.0. Go ahead, say it. I wanna hear it. Okay, what's the next thing after preemption? Memory. I should start talk about memory. So memory miracles. Oh, memory miracles. 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 How do we write this shit? Okay, you fucking pre-cum piece of shit, okay? That's where you go, okay? Preemptive pre-cum, okay. Okay, that's fun. Pre-ejaculate, that's not even a fucking word, okay? How do we pronounce this correctly? Miracle. Miracle.
Miracle.
Miracle.
Miracle.
Miracle. Fuck! Okay.
Miracle.
Miracle. Yeah, we go for miracle here. Oh, that's a fucking lie that I want to tell. In a new file system. Oh, okay. New. And even a new file system. Miracle. American! Fuck yeah. Okay. And a new file system coming out. Okay. Preemption. Pretentious? No. Preeminent? No. I had a fucking word. Oh, that's triggering when you... Oh, I guess I could do paradigm shift in preemption. Paradigm shift in preemption, memory miracles, and even a new file system coming up. Okay. Yeah, I think we got it. We gotta get on with that coffee. All right. New file system. Where the fuck is Kent? Kent being in the background, just fucking yelling at trees now that he cannot yell at people in the kernel. Yeah. Oh man. All right. You know what? We just gotta get into it. Just gotta get fucked. Let's lower the volume of that music, for me at least, and I always have cold feet with that shit. What else was I thinking before that was fucking my brain? I guess nothing. Maybe a bit more music. Okay. Audacity. All right, let's set this thing up. That's compressed. Okay. Does it work? It does. Does it work? It does. All right. And if I yell, hello and welcome to this new video. All right, we're Gucci. All right, let's get this shit going. Wait a second. I want to be sure that I'm not like repeating the same thing. If we're recording. No noise in chat, please. Lol. True! No, we're not repeating. We should be good. Alright. No, you can yell in chat. I'm probably not gonna keep this cut anyway. Okay. You're gonna be able to see how the fuck I make the things work. Alright. What else did I have in mind? I think that was it. In the video, each time you say RAM, you should put... True, I should. I really should. I don't know how much I'll be invested in the editing of this. Let me go pee and then we're fucking filming, alright? Give me a second. True, Rust. True. If only EMB, if only it was that simple. Alright. Alright, let's fucking go. We're starting off strong with the outside making a bunch of sound, but who gives a fuck? Let's make the big say nothing for like half a second so that we can set up the audio. Hello and welcome to this new video. Today we are going to talk about Linux kernel 7.0, paradigm shift in preemption, memory miracles, and even a new file system coming up. Wait a second, I gotta check that audio. That looks a bit wonky, okay? Maybe I was a bit too close to the mic. Hello and welcome to this new video. Today we are going to talk about Linux kernel 7.0, paradigm shift in preemption, memory miracles, and even a new file system coming up. Okay, going back a little, that would probably help. Alright. Hello and welcome to this new video. Today we are going to talk about the Linux kernel 7.0, paradigm shift in preemption, memory miracle, and even... Fuck, I should have put an S there. Let's do it again. Hello and welcome to this new video. Today we are going to talk about the Linux kernel 7.0, paradigm shift in preemption, memory miracles, and even a new file system coming up. It's not that better, but fuck it, we'll keep it. I guess it's going to be cleared up. So let's get started with the first featured change of the day, which is not actually a feature. I just want to address the mental effect of the 7.0 feature. So Linus didn't make the version change because of a specific feature or because there's a specific break in compatibility. He actually just made the change because he does not like to have big numbers. So he wanted to reduce the minor version number and increase the major version number. So when we know that, we should expect that the release should not be that big. But that's not the case, because people still have their compulsion to push change onto the kernel to have their change inside of that new major version. So even if Linus didn't explicitly make this change because of a bunch of feature or break in compatibility, this release still ends up bigger than a usual release. So that's why we have all of those crazy change. Let's get into it. I don't know if that's a good way to put it, but I guess I'm addressing something there. You're missing the B word at the end. Bitch! Should probably have preemption ready. MB feels good about it. We're good. Okay. Alright. I'm going to move my hands a lot in this one, okay? That's the nature of me explaining these things. I'm going to be like that. Okay. So in this release, we have a paradigm shift in preemption. So let's just start by understanding what even is preemption. So preemption is the ability for one process to remove another process that is currently running on the core. So for example, when we talk about preemption when it relates to the kernel, we're talking about the kernel ceding its place to another task that requires the CPU to run. Fuck, that's a bad wording. Let's redo that. Why the fuck are people yelling? God damn. There's people doing construction outside. I fucking hate it. Anyway. So this release has a... Why are they yelling? Anyway. So this release has a paradigm shift in preemption. So let's just get started by understanding what even is preemption. So preemption is the ability for a process to remove the running process from the CPU. So if you want to preempt the kernel from running on your CPU, that's a bad wording. Let's do that again. I don't know why. How did I fucking explain this? Let's read this. In Linux, preempt is a mode that defines preemption or the ability of a process to interrupt an already running one. Okay. Okay, maybe that's how I'll go about it. Sorry, I need to clap my hands to signal that this was all retarded. That's how I know in editing that I need to cut a bunch of shit. Alright. So this release has a paradigm shift in preemption. So do I want to say that we are cutting down modes? No, I guess we need to know what the fuck preemption is. Okay. So this release has a paradigm shift in preemption. So before we get into any new things with 7.0, let's actually understand how preemption works. Now, in Linux, when we're talking about preemption, we're talking about the ability for a process to interrupt a running process and to get on the CPU in its place. So the reason why you would want to do that is because if there is a process running for a long time, there is always the need for something more urgent to maybe get on the core. And this can yield some performance improvement or some perceived... Nah, I'm getting too deep into it. I shouldn't. I don't know what the fuck it's doing, bro. Why are they yelling in front of my fucking house? Get the fuck out, bro. What a fucking buffoon. He's alone in his fucking truck yelling. Bro, get your meds. Anyway. Let's cut it out. Alright. What am I trying to get to here? We need to understand that preemption is removing a running process in order to put another one in. Then I need to explain that historically, preemption was the use of con rescad, of might sleep, and might rescad, and that there were all of these modes. And that now we're trying to push all of those modes. We cannot hear the trucks. Yes, I know that you cannot hear it. It's just, it's fucking mental. Like, when you hear somebody yell, like, at least my instincts is to be like, oh, is it me? Like, I know it's not me, but fucking hell. Okay, let's just read this so that I know where I'm getting at the end of this. Arch that are not capable. Okay, yeah, so... Yeah, exactly. So, okay. So we have to talk about the fact that architectures are kind of fucked. The fact that, yeah, we're gonna enter into that. Okay. All right. So in this release, we have some crazy change. Nope, we have some... So in this release, we have a paradigm shift in preemption. So before even thinking about what change happened to the kernel, we need to understand what preemption even is. So preemption is the ability to remove a running process from the CPU in order to put another one in. Now, you would do that for a lot of reasons. So sometimes you would want to have something that makes the computer feel more, fuck, I don't need to get into this. I shouldn't go into this. We don't care about this. We just need to get onto it. Who gives a fuck? Okay. Okay. So in this release, we see a paradigm shift in preemption. So before even talking about anything related to preemption, we need to understand what it is. So preemption is the ability to interrupt a running process and to remove it from the core to... Can I just fucking read this? Fuck. So in this release, we have a paradigm shift in preemption. Now preemption... I'm fucking the order. So in this release, we have a paradigm shift in preemption. So before even understanding... Why am I mixing everything up? So in this release, we have a paradigm shift in preemption. So before even talking about any change, we have to understand what preemption even is. So preemption is the ability of a process to interrupt an already running one. So this is done inside of the kernel by a bunch of cond resched, which tells the system that preemption can happen. So this is kind of a weird hack because you need the devs to know that the cond resched is needed. So if you are a file system dev, well, you would have to know that at some places inside of your code, you have to place these commands in order for preemption to even happen. Now, this was the case that those commands were sprinkled in everywhere in the kernel, but there was a push to try to remove them. So it's already a bit better, but maybe I need to explain the preemption modes because they're, in what order do I want to do this? The start was good, the part with cond resched, maybe I should put it back. Yeah, I can do this and then go through all the preemption mode. And while talking about the preemption mode, I can talk about cond resched. Yep, that's probably it. So in this release, we see a paradigm shift in preemption. So before even getting started talking about this, we need to understand what preemption even is. So preemption is the ability of a process to interrupt an already running one. So the way that the kernel will do this is by setting a preemption mode. So there is multiple preemption mode. There is preempt none, which essentially has no preemption at all. Or, well, you can have some preemption, but you need to have a specific command inside of your code called cond resched in order to have preemption happen. So essentially, if you don't have this call inside of the kernel code, no preemption can happen while you're in the kernel. Now there is the second mode, which is preempt voluntary, which is essentially the same thing, but with the addition of might sleep and might resched, which themselves are just like on resched whenever preempt voluntary is enabled. Now there is one other mode that was added, that is preempt lazy. So preempt lazy is just like preempt voluntary, but it also adds the ability to preempt at some specific places inside of the kernel. That's not a great way to say it. But it also adds the ability to preempt at some specific moment in execution. For example, when we return from a system call, it can be a good moment to actually preempt because we know that preemption won't create any issue in the running code. Now, there are a bunch of other places where preemption can be done, and Lazy tries to enumerate them and use them in an optimized fashion in order to allow preemption without the use of cond resched. Now, there is also the more crazy version of this, which is preempt full, that's also called low latency desktop. Now, this one essentially allows preemption everywhere that it can be implemented. So even if it doesn't necessarily make sense for us to use preemption at a specific point, it will still allow it because it can. Now, the more extreme version of that would be real-time Linux. So when you go into a real-time kernel, what you're going at is a kernel that has the ability to preempt everywhere. So because it has the ability to preempt anywhere, we also need to change some code in order for it to be preemptable. So the difference between a low latency desktop or a preempt full and a preempt real-time is the fact that we change the code to make preemption possible everywhere, where low latency desktop or preempt full won't go as far as to change the code. It will just allow it where it technically can. Now, the overall goal of adding preempt lazy. Now, preempt lazy is a very recent. Mode. It was actually added in 6.13. We even covered it at the time. Now, the goal of preempt lazy was to allow us to remove preempt none and preempt voluntary, because the use of cond resched is an issue. We cannot rely on the devs to know where to put these cond resched. We could have a bunch of cond resched that are not actually needed, or we could have a bunch of cond resched, which are needed but don't exist. So to remove that, the ability to set points in execution where we know that it's reliable for us to do preemption is really appealing. Now, there is two big issues to that. Now, there is two core issues that we need to address in order to make this possible. The first one is the fact that some architecture are not capable of preempting. Now, the ones that I'm talking about are Alpha, Hexagon, and the Motorola 68000. So those architectures don't have the code to be able to do preemption. So when I say that they're not able to preempt, I'm not saying that like there's some magical thing that prevents the silicon from doing it. I'm just saying that the background code doesn't exist in order to make preemption possible. So we have this issue where whenever we make change to the preemption code, we need to keep in mind that these architecture exist and that changing things can break them. Now, oh fuck, I didn't even address what the fuck the change is. I'll just continue as if we did nothing. Who gives a fuck? I just want to read through this one time and I'll re-record it afterward. Okay. Another issue that we have is also the issue where... Another issue that we have is also the fact that there can be major regressions coming from a change in the execution order of things. So when we assume that some piece of software will always be executed using preempt none, we also assume that there's some specific order that won't be disrupted in that execution. Now, this is not true anymore. Whenever we use something like preempt lazy or preempt full, we can always have some small change in that order. Now, that in and of itself shouldn't cause any big issues, but if ever you have a configuration that is suboptimal, this could become a big issue. Now let's just take a look at one bug report, or one regression report that was made. So there was... You know what, I'll just fucking TLDR it. So there was a bug report that was made that showed that in PostgreSQL, there was a major regression whenever switching to preempt lazy. Now, after further checking, we saw that this was not related directly to preempt lazy. It was more related to the disabling of huge pages, which of course reduce performance gravely whenever we use big chunks of memory. But at the end of the day, when we compare a preempt none and a preempt lazy in this specific unoptimal condition, we see that preempt lazy will fare way worse than your preempt none. So in those weird situations, we might see some issues flaring up, and this is a thing that, well, we're kind of in a weird position, right? Because if the software was configured correctly, we wouldn't have that issue, but also, this issue didn't technically exist before the change to preempt lazy. So this is a weird cost that we have to keep in mind as we go towards integrating new things in preemption. All right, I'll need to phrase that better. I guess, and here I can, like, make it a point to state clearly the change. The fact that they suggested a solution that... Yeah, I want to go into that. It's just that I know right now that I'm getting through it just in order to get through it once. Like this, I don't think is complicated. I'm trying to get into each roadblocks before they actually happen. Okay. Whew, that one's going to be rough. All right. So let's get into the next featured change of the day, which is the AMD Zen 5 address translation that is enabled for use with CXL. Now, the AMD Zen 5 systems can be configured to use something called normalize address. Now, this feature, what it does is it splits in which address type the Now this feature splits which address are used. Now what this feature does is it split which address are used by the CXL endpoint, by the CXL host, and the system. Now the benefit of this split is the ability to interleave your memory across multiple CXL endpoints, which allows for better performance. Now let's just get into how it works to try to understand how this performance is actually created, and how the whole CXL interface not the right word. So and also how the system manage CXL devices. So here we have So here we have a basic map of how CXL devices are arranged. So at the top, we see the system physical address. So this is the whole system memory range. Now, a part of that should be set for the host physical address. Now, that's the CXL's host memory range. So it's the one that the CXL host device that is linked to all the endpoints has. Now, that's going to be hard to explain. Now, let me restart and I'll word this better. So let's take a look about how it works under the hood. So we first have the system physical address. Now this is the whole system memory range as seen by the CPU whenever you process your... That's hard to say. I think I'll just gloss over the fact that there's ambiguity there and that it's hard for us to state what we're talking about here. Okay, so let's get a look of how it works under the hood. So first at the very top, we have the system physical address. So that's the whole system's memory range. Now, part of that should be dedicated to the host physical address, and that's the CXL host memory range. Now, the job of the host is to manage multiple to manage multiple CXL endpoint. So each CXL endpoints will have their own device physical address. Now the issue comes that if you want to interleave all of those memory address, each device together in order to get more performance, you will need to create... How the fuck am I going to phrase that? I don't know how I'm going to explain the performance thing. Can I do it in the same breath as explaining the graph, or do I need to... I guess I could explain it at that step. Okay. So the goal of the split is the ability to interleave your memory across multiple CXL endpoints to allow for better performance. So that way, you could have multiple CXL endpoints that would be able to answer to the same call for a specific chunk of memory. So instead of using one device and the limitation, the read speed and the write speed of one device, you could spread it across multiple devices, thus increasing performance as long as your link between the devices and the CPU is fast enough. Now, just to understand that, let's understand the structure behind these addresses. So here we have the system physical address. So that's the whole system memory range. Now, a part of that is dedicated to the host physical address. That's the CXL host memory range. Now, this CXL host will manage multiple devices, multiple CXL endpoints. So each of those CXL endpoints will have their own device physical address. So from the point of view of each CXL endpoint, they have just a standard piece of memory that they manage. But from the view of the host will need to split each... The host will need to split each... The host will need to interleave all of the data between each device. So for example, we could say that the first 64 bytes goes to the first device, the second set of 64 bytes goes to the second, and the third goes to the third. And with that split, we are able to interleave the data. Yeah, I think that's a good way to go about this. Now here, a very obvious issue occurs. What happens if the device physical address of the CXL endpoint... No. So here, there's a very obvious problem that can happen. what if there is an error to a CXL endpoint, and the error that we get will be referencing a device physical address? Well, then that device physical address doesn't match the system physical address, nor does it match the host physical address. So we need some translation to happen. Now, this translation is done by the ACPI Platform Runtime Mechanism, or a PRM handler. So those are small programs that are created in ACPI source language, and essentially they will do the translation from a device physical address to the system physical address. Now, the implementation and the enablement of these PRM handlers is what we needed in order to get this feature. So now that we have the ability to translate these addresses, we also have the ability to manage these devices, thus having the performance boost when using them in an interleaved fashion. Okay, I think that goes to the core of what the fuck I'm talking about. Hi, Enigma. We're essentially pre-recording before recording the video. Life is treating me well. Treating me very well. Now we're getting out of the featured change, but I still don't feel like we're getting out of the featured change, because in memory management, we've seen some crazy change this release. So let's just get started with the positive news that we have, is that remember in 6.18 we covered sheaves. They were an opt-in feature that essentially allowed to optimize the way that we use cache. So instead of using slab, which is a little bit of a slower way to manage small memory caches, small per CPU caches, we would use sheaves, which are a more optimized way to do things. Now, I'm not going to get deep into sheaves because we covered it only 2 releases ago, but now they're enabled across almost all caches, which we should see some pretty good performance bump from. Now, if we just go on, because like I said, there's a bunch of memory management change that is pretty good here. So we have also the folio clearing code, which has an upgrade. Now, when we were clearing pages, and when I say clearing pages, what I mean is when we are actually trying to get a page, it needs to be cleared by the memory management code. So we need to make sure that a page that is given to the user space is actually full of zeros. Now the code that was doing that clearing was essentially executing itself as a per page thing. So we didn't actually take use of any architecture specific instruction, and there was no way for this CPU to know the extent or the length of all the pages that we needed to clear. So now those things have been implemented, which yields a pretty good buff in performance. So it's really good to see. Now, again, we're going to talk about a lot of things here. So we also have two new functions inside of the kernel, which allows for a huge optimization when it comes to creating huge folios. So with every page and every folios, the kernel will keep a ref count. So this ref count is there to know when a page or a folio should be freed. So if we look at the standard usage of this, so if we have a page, whenever somebody uses it, we do +1 to the ref count, and whenever somebody doesn't need it anymore, we do -1, and whenever it reaches 0, we free it. Now, there are some part of the Linux kernel that will actually try to use this in order to know if we should do something with the page or not. So one example of this would be the page cache. So the page cache will do atomically So the page cache will act atomically upon the ref count. So what it will do is it will check, is the ref count 0? If it's not 0, I want to increment it by 1, and now I'm using this in order to cache the page. So when we say atomically, just to be clear, this is done without a lock. This is done without checking anything else. The only thing it looks at is the ref count, and if the ref count is not 0, it will do whatever it wants with it. Now, the solution to this, the solution to not having the page cache or any other system that does the same thing, the solution to not having the page cache actually mess with the page is frozen pages. So frozen pages is an ability from the kernel to voluntarily keep the ref count to 0 in order to prevent any subsystem like page cache to touch it. So whenever we freeze a page, the ref count is to 0. So if page cache was to actually try to cache the page or do anything with it, it would, well, not be able to, because it would see that it's to 0, so it would back off. Now, this would create a lot of interference before, because you would be creating a folio, the page cache would be trying to cache some pages, but in reality, there's nothing to cache there, right? You're just creating a folio, probably full of zeros. There's no reason why you need to involve the page cache here. So implementing that frozen feature actually allows for huge performance gain. So when we look at the test after the fact, after the patch, we see that the allocation time for 121 gig folios went from 3.6 seconds down to just 0.4 seconds. So this is a crazy optimization for huge folios, and it's nice to see. Life has been treating me, well, no fourth sickness. Well, I'm starting to feel a little bit sick, and I know my daughter's sick too, so, we're getting there, we're getting there. But I'm good enough for streaming, so. Yeah, I think those are pretty easy. I just need to vibe through them the fuck out, because there's like, I think I've searched them enough. It's the thing afterwards that I'm kind of stressed. So another memory management change is the fact that ZRAM can now compress its write back. Now let's just understand each part of this. So ZRAM is a kernel subsystem that allows us to set up a block device that is 1, compressed, 2, stored in RAM, and 3, that can have the backing of another block device. ZRAM can be used as swap or as a simple block device. Now, a write back is when ZRAM takes the data that wasn't used for a long time or that might not be compressible from memory and sends it to its backing block device. Now, before, when a write back would occur, ZRAM would have to decompress the data and copy it uncompressed into the backing device, into the backing block device. Now we have the ability to skip that step and store the data uncompressed. So ZRAM is a big deal because we can have a very strong compression. So whenever we use it as swap, we're expecting somewhere near 1 to 3. So we're compressing to 1/3 of the size whatever we put in it, which means that if we configure this correctly, a device that suffers from a big limitation RAM-wise might perform way better when we look at things like, well, a browser like Google Chrome. So let's just have a quick... So if you want to know if ever you are using ZRAM or not, there's a quick little command for that. So you can use cat/proc/swaps, and if ever it shows up like this, you are using ZRAM, and I'm pretty sure you do. Yes, silence on check, on set. Yeah, I don't know if I said hello. Did I say hello, Nigma, or did I just fucking address your things as if I'm a robot? Hello, Nigma. Happy to see you here. Okay. So we also have the removal of old swap code that was limiting performance in severe RAM limited benchmark. Oh, okay, that's another thing. I should put a dot here. It's been 2 times that I read this and I fucked it up. So we also have the removal of old swap code that was limiting performance. So in a severe RAM limited benchmark, it yielded a 20% performance gain. So here, that feels a bit weak. You know what? I'll put it afterward. All right. Lol. Okay. We also have the optimization to folio reference 1, which is a function that checks and clears the young bit of page table entries. Now, I should explain what page table entries are. Okay. So we also have some optimization to folio reference 1, which is the function that checks and clears the young bit of page table entries. Now, when we're talking about page table entries, we're talking about the entry that is inside of your CPU that allows the CPU to know where inside of the CPU. That's kind of true. We're talking about the how can I phrase this? So when we're talking about page table entry, we're talking about the page table entry, we're talking about the note that allows the CPU to know where the memory is located inside of physical RAM or inside of a file. So it allows us to essentially know what is backing a specific virtual address of memory to some specific physical address of memory. So checking this young bit allows us to know if we should reclaim a specific piece of memory and remove it from physical RAM so that it can be let alone, so that it can be only stored on a block device. So for example, if you have an entire file in RAM that is linked to a folio, maybe you don't want to have that file in RAM anymore because nobody is actually using it. So the way that the kernel will be able to know if you need to remove that file from the physical RAM is to check that young bit on the page table entry, and whenever it sees that the young bit is not there, it knows that it can safely remove it. It knows that it can safely remove the RAM. It knows that it can safely remove the folio from physical memory. I feel like I'm skipping the fact that we're scanning through and we're removing first the young bit, and the second pass actually checks and clears the memory if it's not set to young, but I guess I'll do it better next time. Okay. So the original implementation was reading the page table entries sequentially, which wasted a lot of time, especially when it came to file-backed folios. Now it has the ability to read them in a batched operation, which at the same time uses architecture-specific optimization. The same idea was also used for the batched unmapping of the folios. Now, this optimization yielded a 75% gain with ARM64 and a 50+% gain in x86 in a narrow tailored benchmark. All right, we already read that. You know what? I did a subsystem. I'll go pee. I think we're doing good. But for now, it was the easy part, the part that I overly researched. So We'll see. We'll see. Give me half a minute. All right. We're back. Okay, let's do DFS. So let's get into the first. Oh, so let's get into the file system change, where VFS, which is the subsystem that manages all of the file system inside of Linux, has now the option for a generic input-output error reporting to user space. So file system used to have no standard mechanism for reporting some corruption, some metadata corruption, or some issues with input-output from files. So, fuck, I need to make it clear that it's from user space. Okay. So let's get started with the first file system change, which, let's start with VFS, which is the... Bro, I'm overqualifying too much. Okay, let's get started with the first file system change with VFS, which is the subsystem that manages file systems on Linux, which now has the ability for generic I/O error reporting to user space. So the file system used to have no standard mechanism for reporting any metadata corruption or any file errors to the user space. So that meant that each file system had to implement their own solution on how to signal things to the user space. So the new generic FS error infrastructure was created to standardize how errors should be handled. And as usual, XFS are the first to jump on it. So let's switch over to the changes from XFS side. So of course they took advantage of that new feature, but not only that, they created a tool that is made to automatically heal the XFS from the user space and attempt repair if ever an error is detected. Now this was all implemented inside of systemd, and it shouldn't block any unmounting of an XFS instance if ever you're having an issue, of course, unless you're actively doing a repair. So here what I want to show, that's the laziest fucking thing that I've done all week, okay? I want to show this, right? Because that's the man page of the thing, of the actual program. So that's cute. Oops. Okay. Escape Sweden's first potential recruit. That's fair. Looks like you're doing good. I don't get the escaped Sweden first potential recruit. Are you saying that you were about to, like, get fucking conscripted? Do you have, like, a mandatory military in Sweden? Anyway. Now we also have reduced overhead of the XFS parent pointers. So parent pointers are used in online FSCK, in online file system checks, shrinks, and other complex operation in order to speed up these operations. Now, they work by directly referencing the parent inode that you would normally get from a directory. So instead of having to go to the directory information in order to know who is your parent, you would just look at the parent pointer, which of course when you do these complex transaction like shrink and an FSCK, they are very important in order to make things faster and in order to ensure that everything is okay with your file system. So through some pretty insane optimization, there was So through some pretty good optimization, there was a very... Fucking hell, how do I want to... So through some optimization, they were able to reduce the overhead necessary for that feature. So, of course, before the patch, we had some pretty gross... Fuck, how do I say that? Brain, wake up. So before the patch, we had some pretty heavy overhead in order to create and delete files. So if we look at the create side of things, we would have a 28% slower, prior to fucking hell. How do I compare to baseline? How do I say bench? So the overhead when we compare a system that has parent pointers against one that doesn't is 28% slower to create files and 56% slower to delete files. Now with this new patch, it has reduced this overhead to 8% to create files and 19% to delete it. So this is some very good news because parent pointers are important, and even if they create some amount of overhead, and here keep in mind we're talking about a benchmark that was used to create 32 million empty files. Like, this is not something that you're going to do on your day-to-day basis. You won't feel that actual optimization, even though it's a great thing. It's not something that you're going to encounter an issue with. So parent pointers are cool, and it's cool to see them being optimized. Yep, fun things, especially when I am already stressed. Well, maybe it would be good for you to go and have some fun in the military. Who knows? Who knows, my friend? Maybe it would create something inside of you. New experiences. Anyway. Parents are important. Yes, yes. As someone that is pretty fucked up because of them, I agree. We are important, okay? We are. All right. So now let's switch. All right. So now let's switch to ext4, where we see an improved write performance of concurrent direct I/O. Goddamn. So now let's switch to ext4 when we have improved performance for concurrent direct I/O writes to multiple files. So the way this optimization was achieved is by deferring the splitting of the unwritten extents until the write was completed, so the I/O completion. Now, quick refresher. When we're talking about extent, we're talking about a structure that in its simplest form is a pointer and a length. So we are pointing to the start of an actual data block, and we are then describing how long we have data stored in it. So let's just actually make an example of why we would need to split an extent. So let's pre-allocate an extent of 1 gigabyte. So when we pre-allocate, we put it full of zeros. Now let's only write 512 megabyte of that extent with data. So the original 1 gigabyte extent needs to be split into one extent that is full of data and one extent that is full of zeros. Now, deferring that actual splitting of the extent can do a couple of good things. So the first things is that it can prioritize the more important I/O. So the more important writing of the data can be done before we're actually managing any extent. And the second thing is that we can now possibly write the extent in a more optimized way. So we could see that maybe we could bundle the writing of the extent in a bigger chunk, which would be faster, or maybe we can skip some unnecessary splits. So if we were to split an extent multiple times instead of just one time, then of course we would see a performance boost from waiting and only writing the final product and not each intermediary, extents. What? Where does that come from? Click, bitch! Okay. Now let's switch to F2FS, which... Okay. Now let's switch to F2FS, which now has large folio support for immutable, non-compressed file. So currently there is an overall push. That was a lot of saliva. So currently there is a large push to try to get more folios optimization, especially when it comes to F2FS. So it would not be surprising to me that in the next release we see even more things that are added onto that large folio support. And remember, I forgot I need to explain what the fuck a folio is. How did I fucking skip this? Alright. So we can assume that the people already fucking know what a folio is, goddammit. Alright. Let's kill all of this. Alright. So now let's switch to NTFS. Folio. It's kind of an IO. Kind is king kind of IO created by Dr. Folly. Okay, nice meme, fuck you. So now let's switch to NTFS, where we have a bunch of optimization. Now just to name a few, we have an improved read ahead for bitmap initialization, we have large directory scans, and we have a bunch of other things. I don't really want to get into it because NTFS is getting a lot of work right now, but there's also some alternative driver for NTFS that are popping up. So we might see some more action into that in the next few release, but right now just know that NTFS is getting a lot of change and a lot of work onto it, which is great news. All right. And now let's switch to eCryptFS, which is a file system that we have not talked about. Why did you link that video towards myself in Discord? Ooh, I wanna see. Who the fuck is sending me shit? Okay, Sam just sent me the dumbest fucking thing ever. And I don't know if I should share it. Anyway. Okay. Sam, if you're here, do you authorize me to share whatever the fuck you sent? Anyway. Alright. Nice, a truck. Okay. Nice, another truck. Why are they... Oh, that might be why he was yelling. It's a tow truck. Anyway. Okay. So now let's get into eCryptFS. Now we have truckload of trucks. True! Now we have a truckload of trucks, but eCryptFS is a file system that we have never talked about before. Now this is because this is a fairly old file system. No, it's not old. Now this is because it is a file system that has, well, went to the shadows recently. So eCryptFS was the creation of Canonical. So it was created for Ubuntu 8.10 in order to have encrypted private directories, and in 9.04, it also was implemented for encrypted ohms. Now, let's just get a little bit into how that works. So the idea of eCryptFS is that it is a stackable file system. So the Linux infrastructure, so the Linux VFS infrastructure allows us to create these stackable file system. So another one of those stackable file system could be OverlayFS, that essentially will be in between your real file system and VFS in order to add some capabilities onto your file system. The goal of eCryptFS is to encrypt per directory. So you could have one directory encrypted with a specific key and another directory encrypted with another key. So you can see how this would be appealing to Canonical and to Ubuntu whenever we think about encrypted ohms. The idea of encrypting a home folder with a key that is per home makes a lot of sense when sharing a computer. So in that view, they pushed to have eCryptFS inside of the kernel, and of course it was added back then. Now, in the meanwhile, the support for eCryptFS was dropped in Ubuntu 18.04, and, well, the work on the file system was essentially dropped to zero. So nobody made any change, nobody was maintaining it. Well, there was a maintainer, but nothing was getting done on it. So recently, Tyler Hicks, which is the former Canonical engineer turned Microsoft Linux kernel engineer, and of course eCryptFS kernel maintainer, issued a pull request for Linux 7.0, and you kind of want to pick back up the activity on eCryptFS. So we might see some interesting things there, but I find the concept very appealing. The idea that you don't encrypt the entire drive, but a specific directory, if well implemented like it was with Ubuntu, this could be a winner, right? We could see... This could be a winner because This could be a winner, in my view. The reason why encrypted ohms were not that interesting back then was the fact that computers didn't have the power to support encryption in any meaningful way. Encrypting your whole ohm folder back then was an actual big performance loss, while today encryption is not that of a big thing. People still want to have some, well, part of their system that is optimized. They still want to have that performance gain. So allowing us to have that per directory encryption might be the solution to this. Now, we need to keep in mind there are other solutions that exist than eCryptFS that does essentially the same thing, but it's just good in my view to have another solution on the table to do that. All right. Your words were very sweet, but the truth is that I'm just a retard. Burning through work, and generally I need to learn. Stating stop. More towards my autism whenever I start going out bands. Don't work too much, Nigma. You need to have your own life. I know that you're a young guy, okay? And it's like a... I know how it feels, okay? I'm not saying that I know everything about you, but what I'm saying here is live your life. The life that you choose. The goals that you want. The person that you want to be. It's the complete opposite. That's okay. I'm just stating what I would need to hear 1,500 times if I was talking to my old self. I need to work more, and by work, I mean actual work, not just programming random things. Well, I guess I don't know how much your things are in order, right? I know that you're young and maybe work is not the priority. If you're not in school, yes, you should have work that produces income. If that's not the case, that's your priority. And once that's taken care of, then you should absolutely branch out and have like your hobbies and everything else that you like in life. But yeah, at least from my point of view, the priority of things is like making money to sustain yourself, to put money on the side, to have an actual life where you don't fear like being laid off or like being fucked. If that can be overridden if you are studying, but apart from that, that's the priority. And after that, it should be like, oh, can I find a way to make my life fun? Anyway. Now I want to talk a little bit about something uncommon, which is support for a specific type of SPI NAND, the ADADAD. Now, let's unpack this a little bit. So when we're talking about NAND, just to go very basic here, we're talking about the technology of chip that store data. So SSDs uses NAND chips. Now solid state drive uses NAND chips. So we're talking about these kind of chip. Now, when we talk about SPI, serial peripheral interface, we're talking about the standard for data transmission. So the interface in which we send and receive data from. And that specific interface, the serial peripheral interface, is good because it uses a low amount of pins. So it's really appealing when it comes to Internet of Things. Now, ADADAD, it's also called octal DTR. It specifies a protocol mode. So let's just unpack that protocol mode. So the protocol mode is split in 3 different parts. So the first part is the command. After that, we have the command modifier. And after, we have the data. Now, the number can be 1 or 8. That represents the number of bit of the interface. So if we have a 1D, we would have a 1 bit for that specific command, for that specific mode. And now for the letter, that wording is shit. I should just read it instead. And the letter can either be S for single data rate or D for dual data rate. Now, when we're talking about data rate, we're talking about utilizing only one side or both sides of your clock edge. So this, when we're talking about a patch for adding support for ADADAD, we're talking about adding for an 8-bit interface for dual data rate, where before only the 1S1S1S was compatible, so a single bit in single data rate for all modes. Now, there was a benchmark made to compare the two. It's very good to see for Internet of Things device, so here you go. Alright, well, I'm trying to pudge down my stubbornness, like recently with DWM. I thought making my own text and image editor, so I can escape VS Code. Yes, that would be a big waste of time, Enigma. Absolutely. It would be something that you shouldn't do if you embrace having a life. Unless you want to focus on one thing. I think that's the main thing that, at least to me, differentiate if I give a fuck or not. I could legitimately go for 5 more years of making the kernel parser and kernel info. I could. I would be okay with my life's work being kernel info. So that's why, like, spending oodles of time in that is okay. But the question that you should ask yourself whenever you get into these, like, should I put my time into this or this, is how would I look back at it? If I pull all my time making an alternative to VS Code, will I feel good about it? Or will I feel that it's a fucking waste? Well, I cannot use VS Code nor Krita, what I use from a pixel art, just because I do not have a mouse. Well, then maybe your limitation is a bit retarded here, right? Maybe you should just get a mouse. Do you need a mouse? I'll fucking pay for it. Also, that editor I mentioned is nothing fancy, because I don't need anything fancy. I understand, but you should still weigh in, because you're going to put a lot of time into this, right? Like, that's a... You should have a way to know if you're doing something that you will regret. And if you don't have any way to measure that, believe me, you're going to feel way the fuck too bad for a bunch of things that you shouldn't feel bad about. So, yeah. So here we go with the new file system, which is the pseudo file system nullfs, which was added to the kernel. Now, to even get started into what nullfs is, we need to understand a little bit about how init ramfs work. So in most Linux system, we use an init ramfs to start the system. So it contains the basic binaries, the scripts, and it allows for your partitions to be mounted and the system to start correctly. Now the issue starts when we talk about how we switch the root. So how we take the root from the init ramfs and transfer it to the real partition. So the partition, the final slash that we actually want to use. Now, the way that we currently do it is through something called switch root. Now, switch root is essentially a big hack. So what it will do is it will delete everything from the init ramfs in order to be able to finally kind of unmount it and switch the root over to whatever was mounted by init ramfs. Now, this is very precarious. This is an unoptimal way to do things. So the way that we fix this is by using nullfs, because nullfs, what it provides is a true root from which the init ramfs can mount itself. So because now the init ramfs is mounted onto nullfs, we can allow us... So because init ramfs is now mounted to nullfs, we can now use pivot root, which is a cleaner implementation that essentially just takes the root and change it to another directory. So we can now change from the init ramfs to whatever init ramfs mounted cleanly, and then again cleanly unmount the init ramfs. So it allows for a simpler, better way to start your system. So this is good all the way around, right? We're not talking here about a performance gain or anything like that, but we're talking about whenever you will be working around in your init and trying to like do the things yourself. We're probably going to use this in things like LFN. So this is a cool thing, making the process for initialization within init ramfs simpler. I'm all for that. I have some extra mouse, some vintage with ball. If you want a good one, I offer them to you at Nigma. No caps. Hamster on the table. T-table on hamster. I have a ball man, obviously, but I am using my own incapable incapability as an excuse to escape my stubbornness would be learning those available of keys of my discrew. Okay. At least you know that you're making excuses, I guess. It's just okay. It's very easy for us mere humans to get lost into our thoughts. Like I'm assuming that we're all like very mental people. Like I don't know what to say it. We like to think a lot, and sometimes when you think too much, you can end up in retarded positions. And I just don't want you to not have the small pushback that you probably need in order to make good decisions. Excuses here, being polite, lying to myself. Yeah, we got it. We understood. Alright, let's fucking blow that nose. Also, I am a problem solver, so when I see a problem, I want to solve it. Yeah, I'm like that too. Can I yap half a second of how, like, OP acceptance is? Like, this morning, I did the groceries, and I came home, and I bought a gallon of juice, okay? Like a 3-liter fucking gallon of juice. And I pull it out of the car, and I drop it. It fucking, like, it blows up. Like, I was there just looking at my gallon. Took 2 seconds to be like, okay, I lost a gallon of juice. Well, I didn't lose it. I have, like, a little bit of it. So I'm like, okay, it happened. And I moved the fuck on. Like, taking the time sometimes to just, like, accept a loss is a good thing, okay? I just wanted to yap about this. It's very important in my life. So I want other people to do it as much as possible. That is where the offer from for the mouse come from. Oh yeah. Indeed same, but the problem is I always have a handful, so I focus on them instead of focusing on more important things first. I do not know why, just my... Well, maybe you should fix that, right? Because what you're talking about is a bottleneck, right? So that's the pipeline, right? Pipeline to get there. And essentially, you have this big-ass thing that is blocking everything, and you can fix it just by clicking the button. So there's a button here, okay? You can fix it by clicking the button. But instead of clicking the button, you're going through the fucking internal maze of whatever the fuck this is in order to get there. But maybe you should just learn and accept that you need to click the button, right? I hope that was clear. All right. The close range system calls received a performance boost. Now close range is used to close a range of file descriptors. So quick reminder, when we're talking about file descriptors, we're talking about the way that VFS provides the access to a file to a process. So if a process needs a file, when it opens a file, it creates a file descriptor. And when it closes a file, it closes the file descriptor. Now the change is the ability of the system call to skip already closed file descriptors. So whenever you want to close or create a file descriptor, it needs to go check inside of a file descriptor table. And that table, it will contain, of course, all of the open file descriptor, but also it might have some remnant of the closed file descriptor. So before the change, our speed for running this close range command was the range size. So if you had a bigger range size, even if you had a very limited amount of opened file descriptor within that range, it would take the same time as if there was a bunch of open file descriptor. And now it actually has the ability to only apply itself onto the active file descriptor in the range. So it is way faster that way. So again, it is common for us to end up with a large file descriptor table, and this file descriptor table to be full of open and closed file descriptor. So this will make management of those large process, of those large file descriptor table way easier. I overcomplicated, I was too verbose. All right, we're getting in there, we're getting in there. So now let's get into the architecture change, and let's focus on x86, where Intel now has Intel TSX enabled by default. Now, Intel TSX stands for the Transaction Synchronization Extension, which allows for faster lock handling on compatible hardware. So what it does is it assumes that the lock won't be taken, so it does optimistic execution, and it will run the code locally within the core's L1 cache. So at the end of the execution of the code, it will confirm that the underlying memory didn't change, so it will do that through cache coherency, and it will apply the change atomically. In the event where another core modified the memory, the core will roll back the local change and run the code with the standard locking procedure. This change provides a substantial performance boost given that the underlying code uses the instruction. For example, I finally cleaned, rearranged, reorganized everything I have on the shelves by assembling a new personal computer. Well, that's great. Keep on doing these kind of things. And I excuse that I needed such for said assembly because I don't want to scratch the case paint. Okay. Let me give you a quick hack, Nigma, okay? That's a quick hack. Having a clean, well, in your case, it's probably room, okay? Or having a clean house or a clean apartment. That's the best way to have your fucking house in order, to have your life in order. Because whenever everything is clean, you will want to keep it clean, and you will feel bad whenever there's something like not clean. So keep that up, okay? Clean fucking everything, and you'll see, you'll feel better. Like, it physically feels better. And I know, I'm the kind of guy who's like, doesn't give a fuck. So I need to kind of remind myself to just go ahead and do it. So, yeah. I'm trying to hype, okay? I'm trying to be your hype man right now. Alright, let's switch to ARM64, where we have support for the 64-byte single copy atomic instruction, so LD64B and ST64B, which is possible under ARM v8.7. Now, this is also exposed to Linux KVM guests, so they have their equivalent instruction for, of course, virtual guest. It's now supported. I don't know, there's not much to say there. Oh, man. So now let's switch to RISC-V with the user space control flow integrity and the shadow stack support. Now we've talked about CFI and shadow stack, but now we've talked about CFI and shadow stacks a lot, but just to go through it real quick, it offers protection against fucking rope yourself, okay, against return-oriented programming by using a special set of instructions. So we have zip, zik, flip, filp, flip, filp, filp. What does it stand for? Fuck. LP is for landing pad, and FIS is for shadow stack. Thank you for being my guiding star then. Okay, good. Good, I'm happy. All right. So CFI and shadow stack allow to protect, again, return-oriented programming. So the idea there is that you have a specific set of instruction that allows us to... No, I'll fucking explain it afterward. Okay. So CFI and Shadow Stack, we've talked about it a lot in the latest videos, but it allows protection against return-oriented programming by using some special instructions. So we have zikfilp, we have lpad, we have zikfis, which themselves, what they allow is on one side for CFI, you will have some jump instruction that will have landing pads. So the idea is that you can only return to these specific instruction, and because those landing pad exists, it allows us to make it impossible, or at least very unlikely, for us to execute some code that we're not supposed to while being in kernel mode or even in the user space. So this is great for security. No, I shouldn't say that. And on Shadow Stack side, the idea is to keep a secured copy of the return address of a stack. So whenever we go into a function, we create a stack. That stack has a return address at the end. Well, at the start. Depends how... The stack has a return address. Let's not fucking talk about the position, I guess. The stack has a return address, and this return address could technically be messed with. So the idea of the Shadow Stack is to provide a secured copy and to make sure that that copy cannot be messed with in the same way as the other original return address. So by using that, we can protect against these type of attack where we would redirect to somewhere else inside of our code, which again would not be a good thing. Now there was also a fix against the excessive tag checking, which led to a huge performance loss while using memory tagging extension. Now, memory tagging, what it's there for is to have a set of context for what the memory is supposed to do. So we are supposed to know, hey, is the memory there to be executed? Is it there to only be read? And with that context, we are able to make sure that some memory is not doing something that it's not supposed to. So the issue that we have is that we had a situation where the user space had memory tagging enabled, but the kernel space didn't. So you would have the kernel space do a bunch of checks that it was really not obligated to do. So by making those checks, by making sure that those checks happen only if they are truly needed, we were able to reduce the overhead to a negligible one, as it should. I was doubtful about all of this, but for now, we're doing pretty good. And now let's go into Long Arch, where the improvement continues to the Chinese architecture. So there are benchmarks that shows that Long Arch is making some pretty good progress with their chip, even matching some x86 CPUs in some benchmarks. But let's not get ahead of ourselves, because the CPUs that were compared did not have the same core count. Still, it's impressive to see the gains that they're making, and I'm sure that it is useful on the Chinese market, but at a price of 600 Canadian dollar for board CPU plus cooler, better performance per dollar can be found on x86 AMD and Intel. Now let's cover S390. Yes, I feel like it's rare that we talk about the mainframe architecture from IBM, but they had a crazy change this release. So we're talking about a complete rewrite of the KVM memory management code. So whenever we use KVM, we need to have some kind of frame on how we're going to manage the memory of the guest from the host. So there needs to be some kind of cooperation there in order to make things work. Now, S390 was different from other architecture because it had its own special way to handle the memory management. So it actually limited the use of huge pages, it had impacts on performance, it had a bunch of bad externalities that were created from the fact that there was this unique way that S390 was doing things. Now, IBM dev Claudio M. Breda went on to rewrite essentially everything, and in order to get S390 to be able to use the more generic facilities that allows it to be used like all architectures. So now we can dig into a bunch of the optimization that have been made by all other architectures, and we can get some features like those use pages, like those transparent use pages, like all of the optimization that we're talking about on the folio side are now possible because of that. All right. And I also want to have a little word about some patches that were sent for Alpha, for Spark, and for the Motorola 68000. My question here is, can Linux even run anything useful there? Like we've talked earlier about how the preempt could get into an issue with those old architecture. We see that there's updates on them. Is it even good to keep them? Is it just a cost for us to keep them around, or is there any value to it? Should we set some minimum threshold to what we should expect those architectures to have? I have a feeling that from what we've seen on the preempt side, we could have been further on preemption. We could have been further on memory management if we didn't have to carry over the weight of having those architectures that are not compatible with some fundamental parts of the Linux kernel. So even if we see that there are patches for them, is this a good idea to keep them around? I guess I would like to spark the idea in our mind that it would be reasonable for us to, well, put the limit higher, right? Put the expectations on the maintainer a bit higher for what should an architecture that is viable on the kernel be. And if they don't meet it, well, we should temporarily remove them from the kernel. And if ever they come back and meet those thresholds, I would be more than happy to reintegrate them. Because the idea here is not to make it impossible to have an architecture in the kernel. The idea here would be to make sure that the fact that we have these architecture doesn't actually limit the progress that we have for all other architectures. Yeah, I should say that. Or maybe, would it be better to have a nostalgia kernel? Would it be better to fork the kernel in order to have just the nostalgia patch and them managing things on their own? Who knows? Maybe it is. Network is interesting. I want to get on that before upcoming. Oh fuck, I hate when it does that. Alright. So now let's get on to the network change, where we have a pretty big change. So congestion control, like Swift, requires to have the time of each packet that goes in and out from a network interface. Now, this is done by a function called time counter cycle to time. Now, I hope that this CYC is for cycle, but fuck. Now it turns out that inlining the function, so telling the compiler to copy the code of the function instead of calling the function, gives us a 12% improvement in a stress test. So that's a great catch. But keep in mind that inlining a function is only useful in the hottest of path. So when we talk about hot paths, we're talking about a path where the code will be executed in one way 99% of the time. So this would normally be caught by traditional optimization method, but NIC drivers are mostly compiled as modules, so it makes the traditional tools not work. So that's why this is a big improvement, and that's why it is so impressive. Yeah, that's the feeling, right? Inline fucking everything. Maybe I want GPU first. upcoming is a little boring for me. Alright. So now let's go to the GPU change, where last release we talked about the DRM Nouveau larger pages support, which allows for better performance when using the Mesa NVK, the Vulkan driver. Now the Mesa driver had a bug which prevented the use of the feature, and the bug has since been resolved, so now we're able to use it. God damn. I'm dying. Okay. Alright. And we also have the expand temperature. What the fuck do we mean by And we also expanded the temperature reporting for Intel graphic cards. So the hardware, so using the hardware monitor subsystem, so HWMon, Intel Z-Driver users will now be able to expose the GPU temperature limits, the memory controller temperature, the GPU PCIe temperature, and individual VRAM channel temperature. Cool. I guess we could work queue our way up here. Okay. Now let's just make a little upcoming section where we talk about things that are going to be released, but that right now we can only like talk in a theoretical, that we can only talk about like as things to be coming, I guess. Okay. So let's get into the perf subsystem, which is the subsystem for monitoring hardware, not necessarily hardware, which is a subsystem for monitoring, which added the AMD Zen 6 performance event and metrics. This merge covers the performance counters around batch prediction, L1 and L2 cache activity, the TLB, so table look aside buffer activity, and more. Now, AMD Zen 6 CPUs are set to be released later this year. Now, if we switch over to Intel, we have some perf change of their own with their server CPUs. So we have NTB support for Intel Diamond Rapids. So when we say NTB, we mean non-transparent bridge, which allows multiple systems to share the PCI Express fabric and allow for fast DMA and shared resources. Intel Diamond Rapids CPUs are set to be released later this year. And for Intel Nova Lake, which is a desktop and mobile platform, we have a sound support through the Linux Sound Open firmware driver and display support that was added. Intel Nova Lake CPUs are set to be released later this year. Now, let's go into the other change, and let's get into the big improvement to the work queue rescue. So when we're talking about work queues on Linux, it allows us to set many tasks to be executed when a CPU is free. So historically, multi-threaded work queues would generate one worker per CPU, which... oh, I should probably say... So historically, multi-threaded work queue would generate one worker per CPU per work queue, which would result in a massive number, in a massive amount of processes and wasted resources. The current implementation of work queues will generate a pool of workers that is shared along all work queues, which reduces the memory footprint and processes needed for them to work. With this implementation, the idea of one item in a work queue blocking another from executing becomes a real problem. We wouldn't want one huge process getting all the execution time. To fix this, rescue workers were added to rescue the work queue in circumstances where it might be stuck or unoptimal. An example would be when a system runs out of memory or when a task runs longer than expected. Now, in this release, we see a change to the rescue worker. The idea is that the rescue worker, upon execution, would make a list of tasks and it would run make a list of tasks that it would run and then run them one by one. I guess this is redundant. Is upon execution. Okay. Now in this release, we see a change to the rescue worker. The idea is that the rescue worker, upon execution, would make a list of tasks and then run them one by one. This is suboptimal as there is a possibility for multiple rescue workers being called. This would leave the other workers with nothing to do. Yes, I'll show the picture. The patch makes rescue worker take task. Oh, take task. Goddamn. Take task one by one, limiting this bottleneck. Now I want to take a little word to say that there's been a lot of talk, and the Rust experiment is essentially done. Rust is here to stay. It has been said by Linus and by essentially everyone that has a say in that, well, Rust ain't going anywhere. So if you don't like it, sorry for you. If you like it, celebrate. We got this shit covered. And if you want to put your Rust code into the kernel, make sure that it's clean and you'll be able to do it. You can now change the boot logo. So originally we would have the Tux logo. Tuxedo. We'd have the Tux logo as the image, but now you can select the image of your choice inside of kconfig, so there's no need to edit the source code. So that's a cool thing. And after that, we do like maple time. Okay. I think we got it. Was there anything that was like retarded? I'm going to have to like film it all, but Rust, you can leave now. It's true. I should have a ban moment. Fucking banning Rust. Or no, if I would want this to fit, I would have like a Adas moderator moment. Anyway. It was a good read. Some pickups are needed, but good. Yeah, I feel like the start, like if I keep being enthusiastic, I'll be good. I don't know. I think I'll do it offline. I need to eat. So, yeah. Look, I'll attempt it offline, and if it works, it works. If it doesn't, it doesn't. Who the fuck cares? So it was fun having you. I'll go eat. Go eat and be... It's time for that. Okay? You need to eat. Don't forget to eat. And hopefully, the world doesn't crash in the next thing. So, in the next day. I don't know if I'll stream tomorrow. Maybe it's not reasonable for me to stream considering that I'll be editing the fuck out. So I'll keep you updated on that. So yeah. So don't expect a stream tomorrow and the day after. Saturday. Just reboot if it crashed. If only I'm like here for the fucking rebooting. Trump, go away! Trump, go away! I'm literally like reverse, like Trump, save me from the police, Trump. I'm just like, Linux, save me from Trump, Linux. Okay. All right. So tomorrow and the day after, expect that I'm not here. All right. Make sure that you have saved all that, right? Oh no, that's like no, okay. That's a shit run. I'll redo it offline. Like that's the thing. Like normally I have to read this like 5 times to get it correct. So now I'm trying to reduce that to 2, which is pretty good. But yes, the text is saved. Don't worry, it's all automatic. What the fuck? We have emojis? Or not. Anyway, I'll give you some updates in Discord, I guess. All right? Love you all. Bye-bye. Bye-bye. See you guys. Love you.